across the United States. Different states have taken various approaches to address the contour requirement outlined in Section 680.26c3 of the National Electrical Code, specifically concerning non-metallic in-ground poles. In Ohio, a modification to the NEC 2005 Section 680.26c3 was implemented by removing the phrase "and shall be permitted to be any of the following" from the final sentence before the subdivision. This change mandates that the equipotential common bonding grid extend under paved walking surfaces for 1 meter, equivalent to 3 feet, horizontally beyond the inside walls of the pole. The grid must be in the form of structural reinforcing steel or alternate means as specified in 680.26c3. The grid must also be bonded to all metal parts as described in 680.26 and 680.26c2 that are present. Furthermore, the phrase "the contour of the pole" and was deleted from the first sentence of 680.26c3. Examining how other states have addressed the contour requirement for non-metallic in-ground poles, we find notable examples in California, Florida, Oregon, and Texas. Firstly, California adopted Exception 4 to 680.26c3 in the 2019 California Electrical Code, abbreviated CEC. This exception allows for the use of an equipotential bonding grid that is not contoured for non-metallic in-ground poles. Instead of following the pole's contour, the grid must extend 3 feet horizontally beyond the inside walls of the pole and must be placed on undisturbed and compacted earth or sand. Secondly, Florida mirrors California's approach. Florida adopted a similar exception to California in the 2020 Florida Building Code, abbreviated FBC. This exception allows for the use of a non-contoured equipotential bonding grid for non-metallic in-ground poles, provided the grid is placed on undisturbed and compacted earth or sand. Thirdly, Oregon takes a different path. Oregon does not specifically address the contour requirement for non-metallic in-ground poles in its electrical code. However, the 2019 Oregon Structural Specialty Code mandates that the reinforcing steel for non-metallic in-ground poles be bonded to the main electrical service panel in accordance with the NEC. This implies that the reinforcing steel can be used as the equipotential bonding grid, which would not conform to the contour requirement of 680.26c3. Fourthly, Texas maintains a more stringent stance. Texas does not adopt the TIA, which stands for Tentative Interim Amendment, that allows for non-contoured grids for non-metallic in-ground poles. Therefore, the contour requirement of 680.26c3 remains in effect in Texas. Finally, it's important to note that many other states have not yet addressed the contour requirement for non-metallic in-ground poles in their electrical codes. In these cases, it is recommended to consult with the local building department for specific requirements in each jurisdiction. The purpose of equipotential bonding is to minimize voltage differences in and around the pole area, reducing the risk of electric shock. This is achieved by creating a common electrical potential among various metal parts and conductive surfaces. The bonding grid, typically constructed of copper wire or reinforcing steel, is designed to connect these elements and ensure that they are at the same electrical potential. Section 680 of the National Electrical Code, titled Swimming Pools, Fountains, and Similar Installations, provides comprehensive guidelines for electrical safety in and around swimming pools. This section covers a wide range of topics, including wiring methods, grounding, bonding, and the installation of electrical equipment. The specific requirements for equipotential bonding are outlined in 680.26. The contour requirement in 680.26c3 refers to the need for the bonding grid to follow the shape of the pole. This means that the grid should extend around the perimeter of the pole, closely mirroring its curves and angles. The intent of this requirement is to provide a continuous conductive path around the pole, ensuring that all areas are effectively bonded. However, some argue that the contour requirement is not necessary for non-metallic in-ground poles, as these poles do not have conductive shells that need to be bonded. They contend that a non-contoured grid placed beneath the pool deck can provide adequate equipotential bonding. The exceptions adopted by California and Florida reflect this viewpoint. The use of undisturbed and compacted earth or sand is crucial for the effectiveness of a non-contoured grid. These materials provide a low resistance path for current to flow, allowing the grid to equalize potential differences. In contrast, loose or disturbed soil may have higher resistance, which could impede the flow of current and reduce the effectiveness of the bonding system. In Oregon, the requirement to bond the reinforcing steel to the main electrical service panel effectively utilizes the pool structure as part of the equipotential bonding system. While this approach does not strictly adhere to the contour requirement, it provides a robust bonding solution by connecting the pool's reinforcing steel to the building's electrical grounding system. The decision of Texas to retain the contour requirement reflects a more conservative approach to electrical safety. By adhering to the original intent of the NEC, Texas aims to ensure the highest level of protection against electric shock hazards. It is important to remember that electrical codes are constantly evolving to address new technologies and safety concerns. The TIA referenced in the context of Texas represents a proposed change to the NEC that would allow for non-contoured grids in certain situations. However, not all jurisdictions adopt TIA, and the decision to incorporate them into local codes rests with the relevant authorities. For those working on or inspecting pool installations, it is essential to stay up to date on the latest code requirements and interpretations. Consulting with local building officials and electrical inspectors is crucial for ensuring compliance with applicable regulations. Furthermore, proper training and certification are essential for individuals involved in the design, installation, and maintenance of electrical systems in and around swimming pools. In addition to the specific requirements for equipotential bonding, it is important to consider other electrical safety measures for swimming pools. These include the use of ground fault circuit interrupters, abbreviated GFCIs, to protect against electrical shock hazards, proper grounding of electrical equipment, and the installation of warning signs to alert people to potential dangers. Regular inspections and maintenance of electrical systems are also crucial for ensuring continued safety. Pool owners should be aware of the potential hazards associated with electricity and water and should take steps to minimize these risks. This includes keeping electrical appliances away from the pool, avoiding the use of electrical devices while in the water, and ensuring that all electrical work is performed by qualified professionals. The information provided here is intended for educational purposes and should not be considered a substitute for professional advice. Always consult with qualified electrical professionals and local building officials to ensure compliance with applicable codes and regulations. The safe and proper installation of electrical systems in and around swimming pools is of paramount importance for protecting the health and safety of swimmers and other individuals. The equipotential bonding grid is a critical component of this safety system, and its proper design and installation are essential for minimizing the risk of electric shock hazards. Different jurisdictions may have different interpretations and implementations of the NEC requirements, so it is crucial to stay informed and consult with local authorities. By understanding the principles of equipotential bonding and adhering to applicable codes and regulations, we can create safer swimming pool environments for everyone to enjoy. Remember that electrical safety is a shared responsibility, and everyone involved in the design, installation, maintenance, and use of swimming pools has a role to play in ensuring a safe and enjoyable experience.